In this video, we're going to continue to look at protein degradation. And when we look at cytoplasmic proteins, we can actually predict how long they're going to last in the cytoplasm just by looking at what residues on their N-terminus. So if you have an asp, arg, lu, lys, or phe, you're usually only going to live 2 to 3 minutes. While if you have an alla, gly, met, ser, thur, val, you're going to live over 10 hours if you're a prokaryote and over 20 hours if you're a eukaryote. And this N rule is due to ring E3, which causes our E3 enzymes to bind to destabilizing N-terminus so they can be ubiquinated. Also, if your protein has a lot of proline, glutamic acid, serine, or threonine, PEST, you're going to be phosphorylated, or you're a target for phosphorylation. And this can cause ubiquitination to happen again. You get a bunch of ubiquitins, and again, you're a target to be destroyed. Now, if we look at some examples of what type of proteins can be destroyed through ubiquitination, you have your cyclins. These control your cell cycle, and they'll be selectively degraded by ubiquitination, which is good because depending on what cycle or what state you are in the cell, you might not want to divide yet or be in different phases of PMAT. And like I said in the previous video, you can just have monoubiquitination or sometimes even diubiquitination, and this can control the activities of proteins rather than degrade your proteins. Now let's look at how we destroy proteins once they're ubiquitinated, and that's through this large complex called the 26S proteasome. And you can see from our images here, we actually don't know exactly what it looks like. We just have a rough idea, and this will be using ATP to destroy our protein. So we have a core that is hollow. This is our 20S segment, and you have two 19S caps, and this 20S has a bunch of different alpha-like subunits, or 7 alpha-like subunits, so alpha 7, 6, 5, so on and so forth, and 7 different beta subunits. And you have just 4 stacked rings where the outer are alpha and the inner is beta. Now only beta 1, 2, and 5 will break down our proteins. Beta 1 will cleave an acidic residue, beta 2 will cleave a basic residue, and beta 5 will cleave after our hydrophobic residues. Once we do our cleaving, then these peptide fragments can diffuse out, and then we can use them for other purposes. Or if you're still in a fragment, you can further chop them up using a peptidase. Ubiquitin, we don't want to chop that up, so that will be returned to the cell so we can ubiquitinate other proteins. Now, how this actually works, we don't really know. We know the 19S will recognize our ubiquitinated proteins, and that will help to unfold them and feed them into 20S. But it's very hard to know exactly what's going on, especially since our structures are very coarse, not well defined. And that's it for this video. I will see you in the next one.